Alright, so we're going to start looking at some of the angle measures and properties inside of triangles. And I'm sorry, inside of circles. And there's different ways this could look. We could have a vertex at the center, that's a central angle. We've already looked at that in a previous chapter. We could have the vertex inside, we get the vertex on, and we get the vertex out. We have different properties for how this works and what it does to the angles and the segments as we look through this. So what we're going to look at today are the vertex on it, and we call that an inscribed angle. Alright, and an inscribed angle has an intercepted arc. So if this is my inscribed angle, the arc over here is what it intercepts. That's kind of what it cuts off as we look at it. And we're going to look at those pieces as we go through this. So there's my angle, there's my arc, and if we're going to name that angle, right, that's angle Y. And then the intercepted arc, it's a minor arc the way it looks, so it would just be ZX as we go through it. Alright, we have this property for this. It works out that our inscribed angle, in this case B, is half the measure of our arc. Okay, so if our arc is, if the inscribed angle is 40, our arc is going to be 80, and vice versa. If we had an 80, we'd get 40. So in looking at our example down here, K is an inscribed angle. It's half of its intercepted arc, which is going to be 110. Half of 110 is going to be 55. So angle K is 55. Now I can use that property for different pieces as we go through it. So if we look at different pieces, right, we have to do the same thing, we just apply it different times. So there's an intercepted arc, right? That's going to be 360 minus everything else. So I have all the other pieces, 50, 70, 130, that's 360 minus all those pieces, which is going to leave me with 110. And now I can build different arcs as I go through this and try to figure out those pieces. So as I look at X, right, and I look at Y, right? Y intercepts that green arc over here. So that's my 50 plus my 110. So I'm going to take half of that value. Right? Half of 50 plus 110 is half of 160, should be 80. Now if I look at G, this one down here, right? I have the intercepted arc is 70 and 50. That's going to be 110. I'm going to have half of that. So half of that is going to be 60. Now if I leave my arc measures but try to clean it up a little bit, I look at E. There's E, and I can see it intercepts that whole arc, which is 130 plus 110. I take half of the sum of those two things, that's the whole arc, and I get 120 degrees. And then for F, I'm going to look at what it intercepts, and I'm going to take half of those values, 70 plus 130, and I'm going to get 100, because 70 plus 130 is 200, half of that is 100. So that's it. It's the same principle over and over again as we go through it. All right, we have some corollaries or things that follow from that. And basically, if two inscribed angles intercept the same arc, they're the same angle. An angle inscribed in a semicircle is a right angle. So a semicircle is 180 degrees. So if we just take half of that, we get 90, or the right angle. And then opposite angles of a quadrilateral inscribed in a circle are supplementary. Well, they're going to, if we look at a quadrilateral, basically the opposite angles are going to be, when we look at the inscribed arcs, they make up the whole circle. And so half of 360 is 180, and that's where we get from there. We don't really have to use that one a ton, but it'll be helpful. So if we look down at this angle, we have EDG. EDG is that. We need this arc over here. That arc over there is 180 degrees. It's half of a circle. And so our inscribed angle is half of that measure, which is going to be 90. If we look at GED, right, GED, where's that? That's right there. I need some measurements on that. Okay, well, let's see what we have. I need to find that piece, which means I know that over there is going to be 80. Okay, the whole thing was 180, so that has to be 100. Now I got to be a little bit careful because my angle here is going to be half of that measure, so that's going to be 50. If I look at AB, so I have arc AB. I need to find the angle that's across from it. That's going to be this angle E over here. So that's going to be 90 degrees, right? But then I have this piece here, which is going to be 60. So it's going to be 180 minus 60, or 120 degrees. And finally, angle G. There's G. I see that's the arc it intercepts. That is going to be 80. Is for the same type of reason that we had over here, where this is 90 degrees. So the whole thing is 180, and that's what's left of it as we go through it. So that's half of that piece, which is 40. All right. It could look different as well if it's on the circle, but I have a point of tangency. Thankfully, it's the same formula. So it's just 1/2 of this angle from this arc that we create here. All right, so if I look at that arc, that's 126. The central angle is the same. It's the same measure. And then if I'm looking at BRT, right, BRT, that's this angle in here. That's what I'm trying to figure out. NRU is half of that. Right? NRU is 1/2 of 126. All right, so 63. Now this one is left up to be 63. Oh, sorry, is 54. Right? Because this is 180. So 180 minus 126 is 54. And this is going to be half of 54, which is 27 as we go through it.